Hello guys! Today I'm gonna discuss about the RSA algorithm, my research project or research essay, and ITE14. In this discussion, I'm gonna discuss about first its introduction, how it came to be and who made it. Second is its methodology, how we're gonna implement it in a code. Third is its runtime analysis, or how fast it is when you implement it. Fourth is its advantages and disadvantages. And lastly, its application to the real world. Did I forget something? Oh, right. I forgot to introduce myself. Hello guys, I'm June. I'm currently studying computer science at Caracas State University, and I'm at second year. This video is about our research project in ITE14. Hope you enjoy watching the video. What is RSA algorithm, you say? So, the RSA algorithm is named after its inventors, Ronald L. Travis, Adir Shamir, Leonard M. Adelman. The RSA came from their last name, which is Reves, Shadir, and Edelman, in short, RSA. RSA is considered to be the most secure way of creating public keys and encryptions in crypto systems. The RSA algorithm is also called an asymmetric cryptography algorithm. This means that it has two keys, meaning the public key that is shared publicly, the private key that is kept hidden. These two are different keys but are linked mathematically. This can be discussed further on. So, what is the difference of asymmetric encryption and symmetric encryption? So first is symmetric encryption. In symmetric encryption, you only need one key to encrypt and decrypt a text or a data. As you can see here, enter a plain text, you encrypt it with a key, and then you get the encrypted text. And if you want to decrypt the key, you enter the same key that you encrypt the text with to decrypt it. That is the idea of symmetric encryption. So, what is asymmetric encryption? In asymmetric encryption, you have two keys. One key to encrypt the text or data, and a second key to decrypt the text or data. So here's a plain text. If we're gonna encrypt the text, we're gonna need the public key encryption of the RSA. Then we're gonna get the encrypted text. If we want to decrypt the text, we're gonna need the private key encryption to decrypt the text. We're gonna get our data. That is the idea of asymmetric encryption. So, here in the methodology, how does the RSA algorithm work? So, there's a simple flowchart. I found it in the internet, so I'm gonna explain it. So first, we're gonna choose two primes. If we wanna implement an RSA algorithm that is like how we implemented now, we really need very large primes. We have two large primes. Either it's a 124 bits or 248 bits, just to make it secure. Next is for it to solve the two primes. We need to compute for the n, the phi or the totient, the d, and the e. Then we're gonna find the public key. The public key is the e and the n value of these two primes. The private key is the s and the n. Oh wait, the d and the n of these two primes. The next, the public key is used to encrypt a data, which will be our resultant text. Then a private key is needed to decrypt the data, which will be again our resultant text. So, if you want to code this, we're going to explain it in code. So here, you can start at the start. So this code, we're gonna choose 1, right? 1, giving you a choice to enter a file or a file of text to be encrypted, or you're gonna enter a text as a string to be encrypted. And after that, you're gonna enter the first prime. When you enter a prime, the prime will be checked if the code will check if the prime you've entered is a prime number. If not, it's gonna return not prime. Same with the second prime. If you enter the second prime, it's gonna check again, and if it's not a prime, it will go back here. And after that, it will call the function RSA encrypt. RSA encrypt. So we're gonna go there. RSA encrypt. Here it is. The RSA encrypt function. So to encrypt, we're gonna find the N, the phi, and the E. The phi is the same with the totient. In the internet, they say it's totient, but you write it as phi, so it's the same. So because we're gonna encrypt a string, we're gonna initialize an ASCII code, 1 and 2. The 2 is a temporary data. And we're gonna len, the key, the len, the K, and the J. So what is the key? The key is our E. So what's the value of an E? So first, to find the value of E, you're gonna find first is the N. So we're gonna go up and it's the N. The N is the product of 2 primes. So if we want to run the code, so where is it? First, I'm gonna start. I'm gonna enter a string. Let's see. Hello world. What is our text? We enter a prime, which is 7. 7 is a prime. Next is 13. 13 a prime? Yes, it is a prime. So if we multiply 7 and 13, we're gonna get the value of n, which is 91. It's simple, right? We're gonna multiply 7 and 13. But if you have a very large prime in 120 bits, 1024 bits or larger, this the multiplication will be a very long task to handle in a computer, in a simple computer like mine. Next is we're gonna get the value of an E. So to get the value of an E, you need first to find the phi. So how do you find the phi? So to find the phi, you only need to subtract 1 from the 2 primes. So if you have 7, as our first prime, we're gonna subtract 1. And it will be 6, right? And if you have 13, you're gonna subtract 1. And then equal to 12. And you multiply the 2. That's how you get the phi value. So to find E, this is it. This is the hard part of the code, right? So first, we're gonna initialize the flag as 0. Flag is used to check if the number that we generated is a prime or not. So here, the value of an E must be greater than 2, which is here in our I, but less than to phi. So this is how we get the value of an E. The VE is greater than 2 but less than to 5. So the I here will be R generated. So if we're gonna get the modulo phi and I, it must be 0. If it's 0, then we continue. If it's not, it's gonna go back in the loop until it is 0. Then after that, it's gonna check if it's a flag or if it's a prime. If it's not prime, it's gonna break and it's gonna go back here the loop. If it's a prime, the flag will be equal to 1 and it will be checked. If the value of I is not equal to prime, the first prime or the second prime, which is PR1 and PR2, because if it's equal, it's not gonna be the value of our E, because in another constraints, E must not be equal to the first prime and the second prime that we entered. So let's check here. Now after that, this E, the I will be stored in our E. The E is our global array. Here it is, global array, and we're gonna say it here. This 5, 11, 17, and 19. This whole line here is the value of our E, or possible values. You can use any value of this combination of E and D, and you're gonna still possible to encrypt and decrypt a text using it. So next, you want to find the value of a D. So to be more efficient, we're gonna use the finding of the value of the E and the D. So we're gonna check if the flag is equal to 1, so it's greater than 1, right? It's greater than 0, so it will be 1. We're gonna restore the K. So where is the K? See, the K is we found here. Find D is the function above. So we initialize K as 1. So it will be an infinite while loop until we're gonna find the value of D. So to get the value of D, we're gonna get the sum of K, which is here now is 1, and phi. So the value of our phi is 6,000. So we're gonna get the value of our phi here. I'm gonna write it. Phi value is 6,396, right? So we're gonna multiply and we're gonna sum it with K, which is 1, and we're gonna get the mod of it, using the E here. The same E that we used here to find the same D. If its mod is equal to 1 or greater, it will not continue, and the while loop will continue over and over again until we're gonna satisfy this condition, and then we return the K over E, which will be our D. And this code is 29. That's all. So this will be the possible values of E and D. As you can see here, our private key will be the N and the E. Our public key will be D, and then I forgot to write the N, but here will be N here. So if we continue, this is our encrypted text here. If we press enter, so here's our decrypted text. Lower. As you can see in the methodology, you need 2 different keys to encrypt and decrypt. So here in the code, we need to to encrypt is the K value of E, which is our key. Here we're gonna multiply it or power. So for example, if we had a H, right? So what is the value of H in ASCII? Got it, maybe it's just 26. So if you want to encrypt it, you need to get the power of it. So what is the value of our key? So value of E is our 5. So only gonna do this, and after that gonna mod their answer. The answer of this will be modded. So mod, where is it? Mod of N. So what's the value of our N? It's 91. So we're gonna press 91. So this value, the answer of it, the k, as I say, will be the encrypted data or the encrypted text or letter because it's string and will be stored as character array or string, and it's gonna be translated to a text and stored again into the final encrypted text array. You're gonna loop over the while until it traverses through the string, and then it's gonna print the encrypted text. As you can see here, it's the encrypted text. Then after that, we're gonna decrypt the text, which is called directly here, decrypt len. You only send the len, but you don't need it anyway. So the decrypt bit, you need the first again same initialization, which is the ASCII 1, ASCII 2, the K, the len, the key, and the J, right? And it's the same, it's just reversed. So the value here would be our ASCII, right? So the ASCII 2 will be our number I. So the encrypted text, that is encrypted text. Initialize the K to 0, then this. Our key will be the value of D. So it's the same as this. We're gonna get the power of it, and we're gonna mod it to N. That's why we need two keys, the D and the N, to get this value, translate into a letter, pass it. Here, the -1 is just in the end of the string, to end the string. That's it. Forgot what it's name. I'm gonna print the decrypted text, and here it. This is how you run or implement a simple RSA algorithm. So, runtime analysis. How fast can it run though? There it is. There are three major components of the RSA algorithm. Mainly is the modular exponentiation. You see it in the code, which is this. So you can see this is it. Modular exponentiation. This is the code for that. And its runtime analysis will be log of n squared. Next is the inversion, which is the way to get the value of our D. So the value of our D here, this is the inversion. But it is not a full inversion. If you want to implement RSA using very large primes, you need a mod inverse function and an extended Euclidean algorithm to get the D, which is much far more taxing to your CPU than this simple code. So this is the inverse. Next is modular operations. The modular operations is the adding, subtracting, multiplication, division. So it is total in the big O of log A, or A is the base or the number that you want to subtract or get the sum or product with. So this is the graph of it. So as you can see, the yellow is the modular operations, the red is the modular exponentiation, and the green is the inversion. And for the overall complexity, it will be n squared. Well, as you can see, it will be n squared. In the code, in the code, you can see this in the encrypt and decrypt. You have two nested loops, which is the while and the for. These two loops is equate to big O of n. So I'm gonna type it. This is a big O of n. This, oh no, wait, it is n squared because it is 2 loops, right? In this decrypt function is the same. It's nested in 2 loops, so we have n squared. So the overall time complexity of their code is n squared. If we go like this, you can already see that even if it is a small value of prime, you needed a fast computer for its execution. So now number 4, advantages and disadvantages of the algorithm. So what is the pros and cons you say? So first we're gonna discuss about advantages. Advantages, okay, here it is. First, it's the easy key sharing. So since this is an asymmetric encryption, there are 2 keys. The only key you need to give to the other person is the public key, right? So you're gonna encrypt the text, it's gonna send it to you, and you're gonna decrypt it, just like that. So this type of sharing, maintains the confidentiality of the data. But if the key or the public key is missing, you can't really get it in other way because it's 2 different keys. So you just add in the encryption. It's also say that if the text is somehow or the data is somehow compromised, you or the receiver will know about it because the key will not work with it, or your private key will not work if it is tampered. So that will be the added bonus. Next is the easy to implement. I can see the code. This is easy to implement in smaller amounts. It's moderately and high end, but still it's more easy than the other codes, than the other asymmetric algorithms. Third is easy encryption. So encryption is very fast an RSA algorithm compared to the other asymmetric and symmetric algorithms. And lastly is the stronger security. You can see these 3 ITE2 really shares this stronger security. Because tampering of the data in transit is basically impossible because meddling with it will alter the usage of the keys. And that is for advantages. Next, it's a disadvantage. So first is the slow data transfer. This is apparent. If you're gonna multiply a number over and over again to get its encryption, you're gonna send the number, right? The data of that number. So if you're gonna send it using the internet or any other way, it's gonna be slow because of it. Next is the slow key generations. You can see the key generation has multiple functions. It's needed multiple functions to get the value of n, the value of phi, the value of d and e. So it's here, one of the disadvantages. Compared to asymmetric, or what is it? No. Compared to symmetric key, you only need 1 function to generate the key, which will be the same when you encrypt and decrypt. So it will be much faster than these algorithms. Third is rely on a third party. So I didn't mention it before, but RSA algorithm needs a third party to verify the reliability of the public keys. So if you want to code an RSA, you don't really need to get the value of D. You can also use a third party, especially if it's a very large value of D. Number of computers can't handle it, so you're gonna send it to the server to calculate the value of D and decrypt it. So that's it. And lastly is a slow decryption. It's the same with this, because the data you've sent is a very large number. So if you want again to decrypt it, you're gonna use exponents or modular exponentiation. So the number will be much more higher than the previously or the sent data, and it requires a high processing at the receiver's end for decryption. And lastly, our fifth, which is the application. Let's see, what is the use of this? What is the use of this algorithm? Say so. I'm gonna answer. So the application is for transport layer security, as I say in the advantages, especially in transit data, it's impossible to be tampered with, so that is used. The TLS is used for the internet providers, or if you use internet in general, it is used in some websites that's needed your data. For example, in the Amazon, RSA is used if you want to in sending data, but it's not mainly purely an RSA. It is a compound algorithm. We use another algorithm to encrypt a string and then uses RSA to encrypt that encryption, so it will be much smaller in size and easier to send. So next is for VPN. Really, it is understandable. Virtual private networks or VPNs commonly used now. RSA is used for decrypting your data, or mainly your internet connections from, if you wanna example, enter to another country using VPN, so it is possible and your data will not be tampered with because it is using RSA algorithm. But again, it is not pure RSA algorithm, so it's much more faster. Next is a PuTTY. So for those who don't know, PuTTY is a terminal emulator which provides the user as an interface access to the files on an encrypted server. There's an example of is Google Drive or Mega, like that. Sites like that is a PuTTY for their encryption. Encryption of the data, so it will be easier. Next is Bluetooth, though now you know why Bluetooth sending or receiving is very slow, especially if it's very large, because it uses RSA. So if you want to send a data, it's better to use Bluetooth because it's more secure than the other built-in or third-party apps. Next is internet security or internet in general. RSA is now widely used around the internet, that you can't really go in a site that doesn't use it anymore. So hey, it's the end. It's me. So thank you everyone. If you have any questions, you can write it in the comment section below, and bye.